I'm Madison Decker.
I'm Jocelyn Peebles.
And I'm Maxine McCullough.
And we are 11th graders from Harris County High School, and this is our STEAM Stream video.
What we're doing today is part of the science part of STEAM, and we will be demonstrating density through a density tower.
Our list of ingredients are right here, and you can pause the screen now to gather these things. The ones that we have underlined are optional, but will greatly help you in making your density tower.
Alright, so I'm going to explain to you what density is. So if you want to be fancy and have the definition, it's how much matter or atoms is in a given amount of space or an object. But I want you to think about two houses. Now these two houses are the exact same size, they have the exact same amount of rooms in it and everything. Minus my drawing, even though it's bad, it's okay. So just imagine that they are the exact same size, exact same everything. But in this house, it has, let's say, 20 people in it. I'm not sure how many circles I'm drawing, but it'll be okay. And then in the other house, it has, let's say, 5 people in it. So 1, 2, 3, 4, 5. So you can clearly see that this one is more dense because it has way more people in it and it has a lot less space for the people to move. So it's really, really compact. And this one has a lot of space, so they could dance, they can do whatever they want because they have so much space to move around. So it's less dense and less compact.
Go ahead and pause the video now if you would like to write down the definition of density. So another thing that people often confuse with density is weight. So what is the difference between density and weight? So density is how much matter is in an object, right? Weight has to do with the Earth's pull on an object. So weight is going to be different if you're out in space or on another planet. Density will never change no matter where you are in the universe. So let's go back to Madison's house analogy. But this time, we're going to have a small house and then a really big house. So in both of these houses, we're going to put 5 people. Those 5 people are the same exact people, so they're going to weigh the exact same. But these people have a lot less space than these people do. They're more dense, they're more compact. So their density of this house is going to be a lot greater than the density of this house.
Now if you want to go above and beyond in this lesson, here is a formula for density. Density is equal to mass divided by volume. Now let me break this down for you. Mass is the amount of matter in an object or the amount of people in a house. And volume is the amount of space something takes up. Now the density for water is 1. And we use water's density as a thing to compare to all other objects or liquids or gases. So a real life example of this would be when you are throwing a beach ball through the air, it's easy. Now when you're trying to throw a beach ball under the water, pass it under the water, or hold it down, it keeps wanting to rise up, and that is because the density is less. So any objects that have a density less than 1 are going to be above water, are going to float. Anything that has a density greater than 1 is going to sink below water. So now we're actually going to make our density tower using water, syrup, and vegetable oil.
It's very important to use vegetable oil and not corn oil because the densities are different and your results of your experiment will be different than ours. Okay, so now to begin our experiment. So y'all are welcome to use a jar or you can use a water bottle. If you're going to use a water bottle, we suggest using a funnel. That's why we said it was optional, just because it's a little bit hard. It's a smaller hole than the jar has. So we're going to go ahead and use a jar. And then Maxie.
And so because we predicted that the syrup was going to be the heaviest in density, we are going to put it at the bottom. So we're just going to cover the bottom of our clear cylinder, or whatever you're going to use, in a good amount of syrup, just so you can see the bottom.
So if you can't see, we have our clear layer of syrup. And then next, just so you can really see the difference in colors, we're going to put food dye inside of our water, just so the clear might be a little bit hard to differ from the vegetable oil, but it's completely optional. You don't have to do it if you don't have any or anything. So we're just going to go ahead and put a few drops in there. And you're going to put the lid back on, shake it up real good so it gets all through. See? All right, and then we're going to go ahead and pour it on top of the syrup in our jar. So you can see it, we'll do a close-up later just in case, but there is a very clear difference between the two.
And so now we have the vegetable oil. We are going to pour some on top.
Pour a good amount just so you can really see the difference in the layers. Let's see. It might take a second for them to separate just because of the pouring in.
Density applies to everything, not just liquids. So if we were to drop a penny in it and it were to sink, we know pennies are more dense than all of these liquids. So what do you think? Do you think it's going to sink or float? Now let's try putting in glitter. Where in the density tower do you think glitter will land?
As you can see, our glitter is very slowly sinking to below the water. Because of this, we can conclude that our glitter is more dense than water, but less dense than syrup. So it would go somewhere around here.
To conclude, density doesn't change no matter what happens to the object.
From this video, we hope you learned that the density of water is 1, and that we use that to compare the density of other objects, liquids, gases, etc.
Thank you for learning about density with us today.